Hello and welcome once again to the Aakash BYJUS JEE channel. My name is Atiullah and I'm back with another live session, this time on JEE Solution Plus. So before we start this session, just let me know if I'm audible properly, if you can hear me, if you can see me right, so that we can proceed with this session. Just give me a thumbs up, give me a yes if you're able to see me clearly and if you're able to hear me properly. Hi Dipanshu, how are you? I'm doing very good. So just give me a yes. Okay, Dipanshu says yes. All right. Veena, how are you? How is it going? Festival season round the corner. Are you guys excited? All right, Amrit, thank you for letting me know. Hi Sitaram, how is it going? How are you guys? All right, perfect. So we are live with another session of JEE Solution Plus. So if you have been following us, you know that here you don't just get solution, you get Solution Plus. Okay, what is plus? We're going to delete your misconceptions and strengthen your concepts. So if you're ready, we are going to start this session. All right, so the topic we have chosen for this session is friction, because friction is not an easy force to deal with. There are a lot of concepts involved and there is so much that we have to keep in mind when we are solving questions on friction. Okay, so I'm going to throw a question at you. This is a question based on friction. So let's see how you attempt it. Okay, so let's start this question. So we have to find out what is the tension in the string AB. What is AB? This is string AB. We have to find what is the tension in the string AB and the acceleration of the blocks shown. Okay, so you can see that there are 4 blocks and then 2 of the blocks are kept on a horizontal table. The coefficient of friction between the blocks and the table is 0.5 for both the blocks. The strings are massless and the pulleys are also massless and frictionless. Okay, so we have to find out what is the acceleration of the blocks and the tension in the string AB. Okay, so go for it. I'm giving you some time to attempt it and let me know what is the answer. Okay, or at least you can tell me how do we proceed with this question. What is the method we are going to follow? What are the concepts involved? What do we need to keep in mind? How are you going to attempt this question? Just let me know quickly. Okay? Any answers? Or at least let me know what should we do and at least how do we start solving this question? Okay, so Swastika is asking a question. Sir, अब से Solution Plus का 10 AM session नहीं रहेगा. Right, Swastika, for JEE Solution Plus, we have one session. In that both the sessions, we are going to, in that one session, we are going to deal with both the things. We are going to throw the question at you, see how you attempt it, discuss the misconceptions, and then solve it to give you a complete picture of the problem. Okay. Has tension a specific formula? So Santosh is asking, has tension a specific formula? So if you mean if there's any specific formula for tension, then no. We don't have a specific formula for tension. So depending on the situation, so tension you should understand is a self-adjusting force. Depending on its surroundings, depending on other forces, we can calculate the value of tension. So we cannot have one given formula, one specific formula for tension. Okay, Mani Darpan is saying acceleration of all the blocks will be same. That is perfect. That is great. That is the right approach that you are taking here. Because first of all, we have to find out what is the relationship between the accelerations of all these blocks. And since all of them are connected with single strings, okay, so this block is connected to this block by a single string, this block is connected to this block by a single string, and so on for this block, which means the acceleration of all the blocks are going to be the same. That is absolutely correct. But how do we proceed from here? All right. So whenever we have a question on Newton's laws of motion, whether there is friction involved or non-involved, the first thing is to draw the free body diagram. Okay, so I'm taking G as 10 meter per second square. So I'll start drawing the free body diagram. So on this block, there will be a force of 4G, or I can directly write it as 40 Newton. Okay, there will be a force of 40 Newton. The weight 40 Newton is going to act downwards. Then in this string, we are saying that the tension is going to be T1. Then the tension here is also going to be T1. Then we have 40 Newton acting downwards on this block. And there's going to be a normal force. Let's call this N1. And also there is going to be a frictional force. Is that correct? Also on this 3 kg block, we're going to have this 30 Newton acting downwards. There is going to be a force N2 upwards, and there is going to be friction acting in this direction. And also there is string between the blocks, which means there is going to be a tension T2 over here and a tension T2 over here as well. Okay. Then when we come over this side, there's going to be a tension T3. Then there is going to be a tension T3 over here because it's the same string, and there is going to be 30 Newton force acting downwards. Okay. So this is the free body diagram. Now, since I have understood that the acceleration of all the blocks are going to be the same, then I can assume the acceleration of all the blocks as A. The magnitude of acceleration of all the blocks as A. So A is moving in this direction, as in downwards. This block is going to move towards the right. This block is also going to move towards the right, and this block is going to move in the upward direction. Okay. So I have written all of this. Now all I have to do is I have to write the equations for the individual blocks. Okay. So for this block, for this 4 kg block, I'm going to write 40 minus T1 is equal to 4 into A. Basically, I'm writing the net force in the direction of acceleration is equal to mass times acceleration. Okay. Now I'm going to write this equation for this 4 kg block. But for that, I'll have to look at friction. Okay. For that, I'll have to look at friction. Now we are assuming here that the block is moving, which means what friction is this going to be? This friction is going to be kinetic friction. And what is kinetic friction? Kinetic friction is equal to mu times N. So from here we can see that N1 is going to be 40 Newton and mu is 0.5, which means the frictional force acting here is going to be how much? It is going to be 20 Newton. Do you agree? This friction is going to be 20 Newton. And similarly on this block, the normal force is going to be 30 Newton. The coefficient of friction is 0.5. Hence the friction is going to be 15 Newton. Do you agree? Okay. So now we are in a position to write the equation for this 4 kg block. So this is going to give me T1 minus T2, and then I have friction. So this will become minus 20 is equal to 4 times acceleration. Then we can write the equation for this 3 kg block. How do we write it? There is going to be T2 in the rightward direction. There is T3 in the leftward direction. So minus T3. And then minus friction. How much is the friction? The friction is 15 Newton in the leftward direction. So minus 15 is equal to 3 times A. And finally, we are going to write the equation for this 3 kg block. How much is it going to be? It is going to be T3 minus 30 Newton is equal to 3 times acceleration. Is that right? Okay. Are you comfortable with these equations? Because this is very basic. If you have studied Newton's laws of motion, then you should be in a position to write these basic equations. Is that correct? Now, in order to find the acceleration, what I see here is I can add up all the equations. And what I see is that this T1 is going to get cancelled here. This T2 is going to get cancelled here. This T3 is going to get cancelled here. And we are going to be left with this. So if I have to write this equation, finally, what do I have? I have 40, then I have minus 20, minus 15, and minus 30. This is going to be 35 and 30, and this is going to be 65. So 40 minus 65 is equal to, here we have 4 plus 4, 8, 8 plus 3, 11, 11 plus 3, 14 is equal to 14A. Hence, A comes out to be minus 25 upon 14 meter per second square. Alright, so the acceleration comes out to be minus 25 upon 14 meter per second square. What does this mean? Can anyone tell me what does this negative acceleration mean? We had assumed the acceleration of this block in the downward direction. We calculated the acceleration and then we found that the acceleration is minus 25 upon 14 meter per second square. It is negative. What does it mean? Can you explain the negative sign? Okay, Samarth is saying mera correct aaya. Alright, Samarth is also saying that direction is opposite. Okay, the direction is opposite. How many of you agree with Samarth? Okay, Mani Darpan is also saying that the acceleration is in the opposite direction. How many of you agree that we had assumed the acceleration in the downward direction and the acceleration came out to be negative, which means that this block actually is going in the upward direction. It is accelerating in the upward direction, which means this block, this 3 kg block, is accelerating in the downward direction. So we can say that the acceleration of the blocks is going to be 25 upon 14 meter per second square, but in the opposite direction to which we had assumed. Do you agree with this statement? Okay, Dharmendra is saying, sir, block is moving up. Alright, so that's what we said. So how many of you people agree with this solution? Samarth is asking, so I was correct? We will get to know that very soon. Don't worry. We are going to discuss that in a lot of detail. Alright, let's understand this. Okay. First of all, when there is no friction, okay, if there was no friction, and when the acceleration came out to be negative, it meant that the acceleration was opposite to the assumed direction. But when friction is there, we cannot assume it. So this is not the right answer. When there is friction involved and we get an acceleration which is negative, it does not mean that the blocks are going in the opposite direction. Not at all. So we have to clear this misconception. Okay? When there is friction and we get acceleration in the opposite direction, we cannot say that the acceleration is going to be in the opposite direction. Okay? Because we have assumed that they're moving. And since we have assumed they're moving, we have assumed the friction to be their maximum. When we have assumed the blocks to be moving, we have assumed that the friction acting is going to be kinetic friction, and the kinetic friction is going to be equal to the maximum value of the static friction, because mu k and mu are the coefficient of static friction and kinetic friction I'm taking to be the same. So what we have assumed here is that it is 20 Newton. We have assumed that the friction acting is going to be 20 Newton. We have assumed that the friction acting here is going to be 50 Newton. And this assumption can be wrong. It may happen that these blocks are at rest. Okay? It may happen that these blocks are at rest. Okay? And the values of friction we have taken are inflated values of friction. It is more than the correct value of friction, and hence we are getting a negative acceleration. So in case of acceleration, in case of friction, when we are getting acceleration as negative, it does not mean the block is moving in the opposite direction. It means that the blocks are going to be at rest. Alright, this is the first misconception that we have to delete today. In case of friction, when we get a negative acceleration, it does not mean the block is moving in the opposite direction. It means that the blocks are going to be at rest. Is that right? Do you agree with this? Is this understood? Alright, Aditya is saying shift to advanced level, it's really easy. Alright Aditya, we are going to shift to the advanced level very soon, so don't worry about it. We're just warming up, we're just starting off with a simple concept. So we have to eliminate the misconceptions at every level, be it very simple or be it very difficult. Alright, so first concept is clear over here. So what we have understood from here is that the blocks are going to be at rest. Now if the blocks are going to be at rest, we need to find out what is the tension, because acceleration we have understood is going to be 0. So we need to find out what is the tension. Okay, so what I'm going to do here is, I'm going to throw another question at you. Okay, first let's understand this. Let's understand this concept and then we are going to move forward. Okay, so what we have here is that we have a 3 kg block. There is a string over here and there is a 30 Newton force in the horizontal direction. The coefficient of friction is 0.5. What will be the tension in the string? What will be the tension in the string? Can you answer that? Quickly, let me know. What is going to be the tension in the string? Quickly, let me know. "30 Newton. All right. Captain Jack Sparrow says 30 Newton. Aye, sir. I have registered that answer. I'll let you know if that is correct or not. All right. Anyone else has the same answer, has a different answer? Let me know quickly. I need to find out what is the tension in the string. 15 Newton. So we have a controversy over here. So Mani Darpan is saying that the answer is going to be 15 Newton. Interesting. Which one is it going to be? Any more answers? All right, so it's very clear. So, okay, another answer we have got, another answer, there's 15 Newton. That's very interesting, and this is the concept that we want to solve, actually the misconception that we want to delete here. Look at this. So first of all, the normal force is going to be 30 Newton, okay? It's too simple to explain. The normal force is going to be 30 Newton. So the maximum value of friction, the maximum value of static friction is going to be 0.5 into 30, that is 15 Newton. Is that correct? Now there could be two situations. There could be two situations. When there is 30 Newton force acting here, there are two forces at play. There is tension over here and there is friction over here. Now tension and friction both are self-adjusting forces. Self-adjusting forces mean that the value of those forces will depend on the external factors. The amount of force that is going to be applied is going to be what is the force that is required. Okay? Self-adjusting forces means कि उतना ही टेंशन लगेगा जितने टेंशन की जरूरत है, और जरूरत क्या है? That we have to keep the block stationary. Similarly, friction is a self-adjusting force. Static friction is a self-adjusting force. तो उतना ही friction लगेगा जितने friction की जरूरत है, ना उससे कम ना उससे ज्यादा. These are self-adjusting forces. Now the question is, which force is going to adjust itself first? So here, let's say the friction is adjusting itself first. So the maximum value of friction is 15 Newton. Now friction is going to increase, but what is the maximum the friction can exert? It is 15 Newton, which means friction is equal to 15 Newton is going to act. Is it enough to stop this block? No, there is a 30 Newton force on the rightward direction, which means tension will come into the picture. And how much tension is required? Tension required is 15 Newton. So the tension acting in this case is going to be 15 Newton. Is that correct? Or we can think of it in another way. There's a 30 Newton force acting over here. Now it may happen that tension is adjusting itself first, which means tension becomes 30 Newton. And tension says that I'm going to take care of it. 30 Newton force is required to stop this block. I'm going to apply 30 Newton force. Friction, you don't have to worry about it. So 30 Newton tension has acted. Now friction says there's no requirement of my force. So friction says I will be equal to 0. So in one of the situations we are getting tension is equal to 15 Newton. In the other situation we are getting tension is equal to 30 Newton. Which situation is correct? Can you tell me? Is case 1 correct or case 2 correct? Obviously both the answers cannot be correct. So quickly let me know, what do you think is the correct answer? Is it case 1? Is it case 2? What do we have here? What is your assumption, or what is your understanding? Is case 1 going to be right or case 2 going to be right? No idea. Think about it. Think about it. Don't give up so soon. Think about it. Okay, so you understand what is the problem over here. And Ronak says case 2. Okay, any more answers? All right, so let me clear this out. When two self-adjusting forces are acting on a body, and those self-adjusting forces are negotiable, as in we don't know what is the value going to be, both those forces are negotiable, in that case the friction is going to adjust first. Okay, so whenever we have two self-adjusting forces and we are not sure or we cannot calculate at that point what is going to be the exact value of the forces, they are negotiable, in that case friction is going to adjust itself first. So case 1 is going to be the right answer, because first friction is going to adjust itself. So friction is going to adjust itself, it reaches its maximum. Now friction cannot do anything, still there is some force required, then tension will come into the picture and then adjust itself. So case 1 is going to be the right answer. So first friction is going to adjust itself and then tension is going to follow. Is that clear? Give me a thumbs up if this is something that you have understood right now. Alright, so case 1 is going to be the correct answer here. I'm repeating myself because it's an extremely important concept and it's so misunderstood. It's not dealt with a lot of care. Okay, so let me finally state this. So when two self-adjusting forces are acting on a body and those two forces are negotiable, in that case friction is going to adjust first and then the other force is going to adjust itself. Okay, is that clear? And if that is clear, we are going to return to our problem. Okay, now let's return to our problem. Now here we have understood that the blocks are going to be at rest, which means there is a 40 Newton force acting over here. So the tension in the string has to be 40 Newton. Do you agree? And if we talk about this 3 kg block, there is a 30 Newton force acting over here. So this has to be 30 Newton. Now listen to this very carefully. This 40 Newton and this 30 Newton forces are non-negotiable. Non-negotiable. What does it mean? That there is no other way for these forces to balance each other. So there is a 40 Newton force on this block and the only force that is acting on it is tension. So it has to be equal to 40 Newton. There is just no other way. Similarly, 30 Newton force is acting downwards. There has to be this tension which is balancing it. There is no other force which can balance it. So it has to be 30 Newton. So 40 Newton over here and 30 Newton over here are non-negotiable. We cannot change these values. These are non-negotiable. Is that right? Now, if that is right, now comes the real problem. Now we have this tension and this tension acting on the blocks, and we have the friction acting here and the friction acting here. Now the tension in this string is a non-negotiable, is a negotiable force. It's a self-adjusting force and it is also negotiable. We don't know what the value is going to be. It is going to depend on the external factors. And friction here is also a self-adjusting force and it is negotiable. Now in this case, which friction is going to adjust first? The friction on 3 kg block is going to adjust first, or the friction on 4 kg block is going to adjust first? Can you answer this? Alright, so the tension and the friction on both the blocks are negotiable over here and they are self-adjusting forces. So the question is, friction on the 4 kg block is going to adjust first, or the friction on the 3 kg block is going to adjust first? Can you answer that? On 4 kg, Captain Jack Sparrow says on 4 kg the friction is going to adjust first. Alright, let's see. Are direction of both friction same? We don't know, Mani Darpan. We don't know. Friction is a very naughty force. Friction is not a well-behaved force. We don't know how friction is going to act. It gives us a lot of pain, friction. It does give us a lot of pain. We don't know. The magnitude of static friction, we don't know. It could be anything between 0 to mu n. The direction of friction, we don't know. It could be anything. So yeah, friction is tricky to handle and we will see how to figure that out. We will see. But the question to be asked here is, does friction adjust itself first on the 4 kg block or the 3 kg block? Okay, so let's try to do both. First of all, can I calculate the maximum value of friction on the 4 kg block? The maximum value of friction on 4 kg block is going to be 40 into 0.5. Okay, the normal force is going to be 40 Newton into 0.5, that is going to be 20 Newton. And the maximum friction acting on 3 kg block is going to be 30 multiplied by 0.5 is equal to 15 Newton. I've just used mu n. Okay, so what I'm going to do is I'm going to adjust friction on 3 kg block first. And if I adjust friction on 3 kg block, the friction is going to act in this direction because 30 Newton is acting in the opposite direction. So this is going to adjust first. So this is going to become 15 Newton. Is that correct? This friction is going to achieve its maximum value and it is going to become 15 Newton, which means that the tension over here is going to become 30 minus 15, that is 15 Newton. Is that right? So the friction on the 3 kg blocks reaches its maximum value, becomes 15 Newton, and then the tension becomes the remaining force, which is 15 Newton. Is that correct? So from here we're going to get the value of tension as 15 Newton, and then if we adjust friction on the 4 kg block first, see what happens. This is 40 Newton. Now friction on 4 kg block, we are assuming that it adjusts first. So the friction is going to act in this direction. How much? It is going to be 20 Newton. Then what is the remaining tension? The remaining tension is going to be 20 Newton. Oh my God. Another problem. If we are adjusting friction on the 3 kg block first, we get tension as 15 Newton. If you are adjusting friction on the 4 kg block first, then tension comes out to be 20 Newton. Again, the same problem. Both cannot be true simultaneously. So which one is true? Case 1 or case 2? What do you think is the correct solution here? Give it a shot. Case 1 or case 2? Obviously, both the cases cannot be true simultaneously. Do you see the problem over here? Case 2, Jack Sparrow says case 2 is correct. Alright, so if you are saying that case 2 is correct, can you tell me the reason why case 2 is correct? Also let me know why case 2, why do you think case 2 is going to be the correct answer or correct situation? Alright, let's look at this. Okay, so I have assumed 3 kg block. I have assumed friction has adjusted itself on the 3 kg block first. So this becomes 15 Newton. So the tension has become 15 Newton. So the tension acting here, which tension? This tension. I'm talking about this tension over here. This is 15 Newton. Okay. This is 40 Newton. So if this 4 kg block has to be at rest, there has to be a force in this direction of how much? There has to be a force of 25 Newton. Is that correct? There has to be a force of 25 Newton towards the left. Which force is this? This is friction. But what is the maximum value of friction? The maximum value of friction is 20 Newton. So, the friction on the 4 kg block cannot exceed 20 Newton. So, this is going to be the wrong choice. So, this situation cannot be true. Okay, whereas if we adjust the friction on the 4 kg block first, then it is going to become 20 Newton. The friction adjusts itself, become 20 Newton. Now the tension is 20 Newton. So this is 20 Newton over here. This is 30 Newton over here. So what is the friction that is required to keep it at rest? There has to be a friction of 10 Newton. Is that correct? Now the maximum value of friction on this block is 15 Newton. So 10 Newton is absolutely acceptable. So this is going to be the right forces. These are going to be the forces for all these blocks to be in equilibrium. We cannot say that one block is going to be in equilibrium, the other will not. All the blocks have to be in equilibrium. So for all the blocks to be in equilibrium, this case 2 has to be the correct case. Is that right? Alright, are we clear with this? But what I want to know from you is why? Why does it happen that the friction adjusts itself on the 4 kg block first? So are we going to do trial and error and then find out? If there were 3 blocks, what would happen? Do we have to apply trial and error on all the blocks? Can you give me a reason? Can you think of a reason why friction gets adjusted first on the 4 kg block. Can you think about it and let me know? Because that is crucial. That is the crux of all this discussion. Choose the largest friction. Okay, that's one answer. Choose the largest friction. Anything else that you can think of? Now we have understood that case 2 is the correct case, but why? The question is why? All right. So if you think, so one of the answers I've got is that on whichever block the friction is going to be, the maximum value of friction is going to be greater, on that block the adjustment is going to happen first. Okay, let's see. Let's test that in this new situation. All right, we have another situation. Here what I've done is I've replaced the 3 kg block by 1 kg block. Now tell me what is going to happen. Now let's see what happens. Something very interesting is going to happen. Now we have already arrived at this point that there's going to be a 40 Newton non-negotiable force here. There's going to be a 30 Newton non-negotiable force over here. Now let's adjust friction on the 4 kg block first. Let's adjust friction on the 4 kg block first. So the friction is going to adjust itself. So this is going to become 20 Newton. And how much is this tension going to be? This tension is going to be 20 Newton. Is that right? Okay, then what happens to this 1 kg block? What is the maximum friction that can act on this 1 kg block? It is going to be 10, which is the normal force, into 0.5, which is 5 Newton. Okay, now talking about this 1 kg block, now this tension here is how much? This tension here is 20 Newton. Now 30 Newtons towards the left, 20 Newton towards the right. The friction has to act in what direction and with what value? The friction has to be 10 Newton in this direction. Do you agree? But the maximum value of friction that can act on the 1 kg block is only 5 Newton. So this 10 Newton is not correct. It's not possible, which means we are going to get a wrong answer. Whereas if we adjust the friction on 1 kg block first, what happens? Let's say this is 30 Newton. Okay. And this 40 Newton again is non-negotiable. So if we are adjusting friction on 1 kg block first, then it is going to be 5 Newton in this direction. Then we are going to have 25 Newton in this direction. So this tension is going to be 25 Newton. Now 25 Newton towards the left, 40 Newton towards the right. What should be the friction? The friction should be how much? The friction should be 15 Newton in the leftward direction. Is that correct? And what is the maximum value of friction for this block? The maximum value of friction for the 4 kg block is 20 Newton. So 15 Newton is completely acceptable. So this means case 2 again is going to be the right case. Do you agree? Think about it. Take a few seconds. Think about it. Absorb it. Tell me if you agree. And if you agree, can you see the problem here? Now, if I adjust friction on the 4 kg block, in the previous problem, what did we do? We adjusted friction on the 4 kg block first, and we got the right answer. Now, in this situation, we adjusted friction on the 4 kg block again, and we got the wrong answer. When we adjust friction on the 1 kg block first, then we get the right answer. Now this is the problem we have to resolve. On which block you need to adjust the friction first? So we saw that it could be both. It could be a both on which the maximum value of friction is lower. There we may have to apply or adjust friction first. So it's not clear from there. We don't get a clear picture. And this is the crux of the problem. This is what we have to resolve. Is that right? Are you able to see the problem over here? All right. So if you have understood the problem, then I'm sure you'll understand the solution as well. So let me clear this entire thing. Let me give you the complete concept. Okay. Now 40 Newton over here is non-negotiable, 30 Newton over here is non-negotiable. The maximum value of friction that can act over here is how much? It is 15 Newton. The maximum value of friction that can act over here is 20 Newton. We have talked about it. Then we have a tension over here, we have a tension over here. Now what we have to do is, which block has a greater tendency to pull? What we will have to see here is that which block has a greater tendency to pull. For that, what we are going to see is, we are going to see this. The tension is same on both the blocks, so I don't have to worry about it. So I have to look at this. So here, this 4 kg block, what is the net pull towards the right? What is the net pull towards the right? The net pull towards the right is 20 Newton. Do you agree? The net pull towards the right is 20 Newton. And in this situation, the net pull towards the left. What is the net pull towards the left? It is 30 minus 15, which is 15 Newton. Do you see that? So on this 4 kg block, there is a net pull of 20 Newton towards the right. And on this 3 kg block, there is a net pull of 15 Newton towards the left. And when I'm saying net pull, I'm saying that if maximum value of friction has acted, I'm taking a situation when maximum value of friction has acted. It's not necessary it is going to act. We just want to see the tendency. We are not saying that this is actually going to happen. We are trying to figure out what is the tendency of the blocks. What does the block want to do? So if we talk about this 3 kg block, then there is a net pull of 15 Newton towards the left. For this 4 kg block, there is a net pull of 20 Newton towards the right, which means the 4 kg block has a greater tendency of moving to the right. The 4 kg block has a greater tendency of pulling the string. So this block, which has a greater tendency of pulling the string, the friction is going to adjust itself first on that block. Okay. So here, because of the mentioned reason, friction is going to adjust itself first on the 4 kg block and then on the 3 kg block. And when we do that, we get the right answer. Do you remember? When we do that, we get the right answer. Let's say, so friction has adjusted on the 4 kg block. The maximum value of friction is going to be 20 Newton. The tension hence here is going to be 20 Newton. The tension here is going to be 20 Newton. Then the friction acting here is going to be in this direction. And how much? It is going to be 10 Newton. It is lower than the maximum value of friction on that block, so it is completely acceptable. So this is the forces. These are the forces that are going to act on these blocks. Is that right? Whereas when we look at the other situation, so this 30 Newton is non-negotiable, this 40 Newton is non-negotiable, there is tension, and then the friction, the maximum friction that can act over here, the maximum friction that can act over here is how much? 5 Newton. The maximum friction that can act over here is 20 Newton. So if we talk about this, the tendency of the 4 kg block, what is the net pull? The net pull is 40 minus 20 is equal to 20 Newton. Do you agree? And if we talk about this, the net pull is 30 minus 5 is equal to 25 Newton. Now in this situation, the 1 kg block has a greater tendency of pulling the string. Is that right? So the friction is going to get adjusted first on the 1 kg block. If we do that, we are certainly going to get the right answer. Okay. So I'm going to adjust friction first on the 1 kg block. So this is going to be 5 Newton. And so the tension is going to become how much? The tension is going to become 25 Newton. Now the tension is 25 Newton, this is 40 Newton. So the friction is going to act in this direction. And how much the friction is going to act is, what is required? 15 Newton is required. So 15 Newton is going to act. Okay, the maximum value of friction that can act on that block is 20 Newton. So 15 Newton is completely acceptable. So this is going to give us the correct relationship of the forces. Do you get this? Alright, so how many of you were aware of this concept? How many of you got stuck with this concept? Let me know. Because it is a tricky concept. It is certainly a tricky concept. Okay, but have we resolved it? Have we've been able to clear your misconception. That is the important thing. I'm not here to teach concepts. I'm here to delete your misconceptions. Okay, I'm here so that we can clean that part which is not right, remove that part which is not right in your learning, so that what you learn is pure, what you learn is correct. All right, Jack Sparrow, thank you so much for understanding this. I am extremely happy that you are able to understand this and appreciate this, and thank you so much for engaging, because unless you guys tell me where you stuck, I don't know what is the problem, and I cannot resolve the problem unless you guys tell me. So it's amazing that you guys are attempting it. I'm so happy when I see students who try to attempt questions, who try to fight it out. They're just not there to listen to the solution. They're there to actually solve it, actually give it a shot, actually try. That's amazing. I love that. And that's how I feel that I've been a little successful in doing my job. That gives me a lot of happiness. Okay, so we are done with this concept. I hope you understand it, you register it, and never forget it. All right, now let's move to next question. All right, the next question is also on friction, and what we have here is that there is a horizontal force of 1000 Newton acting on this block. Then there is a 2 kg block, and there is a 5 kg block. The coefficient of friction between the wall and the 5 kg block is 0. And the coefficient of friction between the 2 kg block and 5 kg block is 0.1. We have to choose the correct options. Okay, you can take g is equal to 10 meter per second square. You have to choose the correct options. Number one option, acceleration of the 2 kg block is 35 meter per second square. Second option is acceleration of the 5 kg block is 14 meter per second square. Both the blocks remain at rest. Acceleration of both the blocks is 10 meter per second square. Okay, are you able to understand this question? Is the question clear? And if the question is clear, please give it a shot. Tell me what is going to be the right answer. Give it a shot. I'm going to draw the FBD separately, don't worry about it, but I'm just giving you the question right now. Now you can draw the FBD, you can try to solve it, okay, but obviously I'm going to discuss the solution in detail, but first I want you to solve it. Okay, I'm repeating the question. The force acting here is 1000 Newton on this 2 kg block, a horizontal force. The coefficient of friction between the wall and 5 kg block is 0. And the coefficient of friction between the 2 kg block and 5 kg block is 0.1. We have to find the accelerations of the blocks. That's it. That is it. Give it a shot and let me know if this is correct. Which of the following options are going to be correct? Or at least tell me, how do we proceed? All right, let's try to understand it. Okay, so obviously what we need is, we need the free body diagram. Okay, so when we look at the free body diagram, there is going to be 50 Newton acting over here. There's going to be 20 Newton acting over here. This is 1000 Newton. There's going to be a normal force on this block like this. There's going to be a normal force on the block like this. Okay, and the tricky part is friction. What is going to be the direction of friction? So before we do that, let's find the maximum value of friction. So then if we look at the horizontal forces on this 2 kg block, then N is going to be 1000 Newton. The normal force is going to be 1000 Newton. If the normal force is going to be 1000 Newton, then what is going to be the maximum value of friction between the blocks? The maximum value of friction is going to be mu N. So it is going to be 0.1 into 100,000, which is 100 Newton. So the maximum value of friction that can act between the two blocks is 100 Newton. Okay. Now we don't know what will be the direction of friction. So let's assume something. Okay, we don't know what is the direction of friction, so let's assume something. So let's say that the direction of friction on the 5 kg block is upwards. If the direction of friction on the 5 kg block is upwards, the direction of friction on a 2 kg block is going to be downwards. Okay, so 50 Newton is acting downwards. So what is the friction required? Friction is a self-adjusting force. The amount of force that is going to act is only the force that is required. So what will be the value of friction so that this 5 kg block does not fall down? It is stationary. It is going to be 50 Newton. Do you agree? If that is going to be 50 Newton, then this friction is also going to be 50 Newton. Action and reaction. So the net force acting on this 2 kg block is 70 Newton. Do you agree? Which means that the acceleration of the 2 kg block is going to be 70 divided by 2, and that is going to be 35 meter per second square. Do you agree with this solution? Let me know, do you agree with the solution or there is some problem with the solution? Alright, what do you think? Is this solution correct or there is some problem with the solution? The acceleration for the 2 kg block is 35 meter per second square. Alright, let's think about it. So there is no vertical force acting on the 2 kg block except for friction, which friction we don't know is going to act in what direction, we don't know. But the thing is, just think about it practically. There's a force we have applied, but this 2 kg block is going down with an acceleration which is greater than g. Does that make sense? Think practically. Take 2 blocks, apply a force. Now one of the blocks we see is going down with an acceleration of 35 meter per second square, which means that it is going down with an acceleration of greater than g. Is that going to happen? That makes no sense. Okay, if you think about it practically, that makes no sense. It cannot happen. Okay, now if that is not true, let's try the reverse case. Okay, when we talk about the reverse case, so this is 50 Newton, this is 20 Newton. What is the reverse case? Let's say that the friction on the 2 kg block is acting in the upward direction, and the friction on this 5 kg block is acting in the downward direction. So in this case, what is the friction required to keep this 20 Newton block at rest? It is how much? It is going to be 20 Newton, which means that the friction here is also going to be 20 Newton, which means the net force acting is 50 plus 20, which is 70 Newton divided by 5 is equal to 14 meter per second square. So we have got the answer of the acceleration of 5 kg block as 14 meter per second square. Now does that make sense? Think about it practically. And tell me, does this make sense? This acceleration has also come out to be greater than g. So we have just applied the force in the horizontal direction, and one of the blocks is accelerating downwards with an acceleration greater than g. Does that make any sense? That makes no practical sense. Okay, so just based on our experience, our practical knowledge, we can discard these two answers, which means we actually have to dive to understand what is the correct answer. Okay, now when we have to deal with the direction of friction, the thing we have to think is, what is going to be their relative motion, their tendency of relative motion? And what decides the tendency of relative motion? The relative velocity decides the tendency of relative motion. Is that right? Okay, so we have to think that what is the tendency of relative motion. For that, what we need to do is we need to forget about friction. For some time, forget about friction. Think there is no friction at all. Okay, think there is no friction at all, and then think what will be the tendency of motion. So for this block, there is a force of 40 Newton acting downwards, For this block, there's a force of 20 Newton acting downwards. The force on the 5 kg block is greater, but that does not decide their relative motion. What decides their relative motion? Their velocities. Okay. So in this case, the acceleration of the 5 kg block is going to be 10 meter per second square, and the acceleration of the 2 kg block is also going to be 10 meter per second square, assuming there is no friction there. So we have eliminated friction, and we want to see what is the tendency of relative motion. So we say that acceleration of both the blocks is going to be 10 meter per second square if there is no friction. And if the acceleration is the same and the initial velocity is the same, won't they have the same velocity with time? Is that right? V is equal to u plus at. If the initial velocity is 0 and the acceleration is same for them, that at any time their velocities are also going to be the same, which means there is no tendency of relative motion between the blocks. And if there is no tendency of relative motion between the blocks, then how are they going to exert friction on each other? They are not going to exert any friction on each other. Is that right? So if there is no friction, the friction on both these surfaces are going to be 0. If there is no friction between them, there is no relative motion, there is no tendency of relative motion between them, then what is going to happen? Both are going to fall together. There's nothing to keep them in their place. There's no upward force. So both the blocks are going to go together in the downward direction. And what will be their acceleration? Both of them are going to have the acceleration of 10 meter per second square. Is that correct? Okay. So let's have a look at the options. So what option is going to be correct? Option 4 is certainly going to be the correct option. Okay, so what have we learned over here? What is the key concept over here? That in order to figure out the direction of friction, we have to look at the tendency of relative motion. And to figure out the tendency of relative motion, we assume that there is no friction between the blocks. Once we assume that, we try to figure out what is their relative velocity, and from there we figure out what is the tendency of relative motion. All right, so here, by applying these concepts, we get answer 4, and that is going to be the right option. Is that correct? Does that make sense to you? Has that cleared your misconception about finding the direction of friction? All right. So I hope this session was helpful for you. I hope I was able to delete a few misconceptions of yours. And if you want to learn more about these things, if you want to clear your misconceptions, you want to revise a chapter, you want to get more funda, or you want to get more insights into how to prepare and a lot of things that are related to your JEE preparation, then do subscribe to this channel. There are a lot of amazing videos that we are creating. Okay, and if I was able to teach you something today, please give me a thumbs up, please give me a like, so that I know that what I'm doing is actually helping you. All right, so that's it for this session. I'm going to see you very soon, and till then, keep learning, keep having fun with learning, and that should be the objective of whatever you are doing. All right, keep having fun. See you very soon. Thank you so much for watching.